Well, hello again. We're now in week 5, and we just have a little bit more to cover. And then I'm going to give you a test slash quiz, which is already made up. It's on Blackboard. By the time you watch this video, it should be available for you to take. So what you should know about that quiz is it's 25 multiple choice questions, and you'll have 2 attempts at it. They are timed attempts. You'll have 90 minutes for each attempt. At the end of 90 minutes, it will automatically submit. So don't just walk away from it, half done. Make sure once you start it, you have enough time to finish it. I'll take the highest of the 2 grades. So what I suggest you do is don't wait too long. It's going to be up all week till Friday at 5. So basically the work week, 8 a.m. Monday till 5 p.m. Friday. And what I would do if I were you is watch, this after you've watched this video, go take the test, and then go back and look through for the things that maybe you got wrong. Go back through the videos, go back through the slides, and then retake the test again, and you should do better. Anything you got wrong the first time, theoretically, you'll get right the second time through. So with that, let me just cover a couple little things. Let me turn this off here, and let's bring up our PowerPoint from before. And let's see, we were down, about here. So this is a slide we were working on. And if you recall, we were talking about kind of this, let me change this color here, kind of this sweet spot here in the air-fuel ratio where catalytic converter efficiency is close to 100%. And what we said, or what I'm saying now anyhow, is that this is not necessarily the ideal air-fuel ratio for everything. If you want more power, you want to be more over here on the richer side. If you want better fuel economy, you want to be more over here on the leaner side. But if you want the best, compromise for the converter to successfully get rid of NOx, HC, and CO, then this is about where you need to be. So, it's a compromise. It's not the best for NOx. The best for NOx is more over here. HC and CO, it's more here, but you're going to give up one to get the other. So right here in the middle, it's pretty good for all of those things. Oh, hang on a minute. Get rid of this stuff. All right. So we already talked about volumetric efficiency. And just as a quick review, volumetric efficiency is a measurement of how well the engine is breathing. That's affected by both the intake and the exhaust. So, things that can affect volumetric efficiency, of course, built into the engine are, engine design, intake manifold, exhaust manifold, intake and exhaust ports, the valves, how big they are, how many there are, how far they open, how long they stay open, the size of the throttle body. Those are all things that are kind of fixed in the engine. Things that change all the time are throttle opening, so that's driver demand basically, and engine RPM, which typically follows throttle opening a little bit. So things to look into here, right, is that when the throttle is closed, right, it's limiting the airflow into the engine, so your volumetric efficiency goes way down. And when you open the throttle and let more air in, then it breathes better, volumetric efficiency goes up. Also, high engine speed limits time air can flow into the cylinder. So at really high RPMs, volumetric efficiency can drop off very rapidly. So as a rule, and this is not completely 100% true, but when you've got the throttle open and something is keeping the engine speed down, that's when you're going to have the best volumetric efficiency and the highest cylinder pressure. And I talk about the cylinder pressure on purpose because this is going to have an effect on our ignition system, so we're going to talk about that really soon. So the other statement here, volumetric efficiency is lowest when the engine's turning fast and the throttle's closed. Think of a situation like deceleration. You're going down the highway and you take your foot off the gas. So you're blocking off the incoming air, and the engine's turning real fast, so its appetite for air is kind of high. So you're throttling it, you're choking it to death. And it doesn't make any power at all when you take your foot off the gas. Alrighty, let me go to the next slide here. This I think I already said this, but in case I didn't, this is my second time through recording this. It's now Sunday night. When I went to play back the original recording, I had no sound, and I realized I had muted my microphone for a complete half-hour discussion, and so this is just a second attempt, and unfortunately may not be quite as good because it's kind of late on Sunday night. Okay, so I have a couple questions here. One is the engine turning slowly with the throttle open, and one is it turning fast with the throttle closed, and which situation would develop more power? So first question, when is the engine turning slowly with the throttle open? Think of this way, you're towing a big trailer up a mountain. So the load from that trailer is holding the engine speed down. Way different than if you just put it in park or neutral and step on the accelerator, and the engine speed shoots right up. With a big load on the engine, of course, that's fighting against that and kind of holding the engine RPM down a little bit. But at the same time, you have the throttle wide open. So with the engine turning relatively slowly, the intake valve is open for kind of a long time compared to how long it's open when the engine's going fast. So there's more time for air to flow into the cylinder. And with the throttle open, there's no restriction keeping air from flowing into the cylinder. So under a heavy load, you're going to have wide open throttle and the engine not turning slowly necessarily because the transmission will downshift, but that load is holding the speed back some. Second question, when's the engine turning fast with the throttle closed? If you drive a manual transmission, you'd know this, when you're going down the road and you downshift, take your foot off the gas, now the transmission's driving the engine, and you have that engine braking going on, and the throttle's closed, so the engine has a high demand for airflow because it's turning fast, but the throttle is blocking that air off. And so your volumetric efficiency and therefore your cylinder pressure is going to be really, really low. So which situation would develop more power? Seems like a dumb question. Obviously, when I take my foot off the gas, I'm not going to develop much power. So, or no power, or maybe even negative power. And when I'm wide open throttle, that should give me the most power. So what I'm trying to get to here and how it relates to the ignition system is cylinder pressure. So cylinder pressure is related to atmospheric pressure, so it can change with atmospheric conditions. It's related to manifold pressure, so that can be affected by throttle opening and other things. And it's affected by the length of the time the intake valve is open. So manifold pressure is highest when the throttle is open. The intake valve open time is affected by engine speed. So what's the relative pressure under these four conditions here? So we don't need to talk about all of these so much, but let's just look at these two. So, under a heavy load, what's going on under a heavy load? This is what I just talked about. You have the throttle open, or maybe even wide open, and that load is holding the engine speed back. So now we have intake valve open for a pretty long amount of time, relatively speaking, and very little restriction to the intake airflow. So, you know, under a heavy load, what do we got? We've got wide open throttle probably, plus, you know, limited engine RPM. We're going to have very high cylinder pressures. Now, if we change to the absolute opposite of that, right? The opposite is decel. So decel, what do we have? We have closed throttle, and we have possibly high RPM. That's going to give us low cylinder pressure. I don't know why I'm randomly choosing to capitalize and not capitalize. So we look at those two extremes, right? Idle and crank. You know, idle, you've got the throttle closed, but the engine's turning relatively slowly. But that closed throttle is the biggest thing here that's going to kind of eliminate, you know, much pressure in the cylinders. And under cranking, kind of the same thing. It might actually be a little higher under crank because, you know, crank, the engine RPM is really low, right? But still, the throttle is closed. So the ones that we really kind of care about, heavy load and decel. So having, you know, listened to all that, let's talk about what happens inside the cylinder when the spark plug fires. So you have resistance across the spark plug gap. Resistance, you know from electricity is, you know, opposes current flow. And we're trying to get current to flow across the gap. What affects spark plug gap resistance? The width of the gap is huge. You know, if you have a wider gap, it's going to take more voltage to jump it. If your gap is smaller, it's going to take less voltage to jump it. But driving down the road, your spark plug gap's not changing. What is changing? Two things are changing inside that cylinder. One is the air-fuel ratio, and the other is the pressure in the cylinder. So we've already talked about pressure in the cylinder. We know when that's, you know, high. And now I want to talk a little bit about air-fuel ratio. So let me bring this up again. Lean mixtures have higher resistance than rich mixtures. So when cars used to have carburetors, there was something called an accelerator pump, and so you would step on the accelerator, and that would open the throttle, which lets more air in, of course, right? So now you have this going on. You open the throttle, you have more pressure in the cylinder. That gives you higher resistance. Whoops, higher resistance at the spark plug. If you leave it lean, now the combination of that high pressure and lean air fuel mixture is going to create the need for really high voltage in order to jump that spark plug gap. If we throw a little extra fuel at it, enriching the mixture, right, that's going to help fix this problem here and reduce the resistance across that spark plug gap. So what are the worst conditions for creating a spark? Think about it. If you have both high pressure, so what causes that? You know, wide open throttle, heavy load, and lean air fuel mixtures, that's going to be the worst condition for creating a spark. It's going to require the most energy out of the ignition coil. Turn this off here. Whoops. I did not want to do that. So let me put my smiling face back on here and talk to you for a minute about that, because I have a story that several years ago, and we were working on I think it was a 2003 Ford Crown Victoria. And that's not exactly the latest and greatest technology, 17 years old, but a lot of things were the same then as they are now. Fuel injected, port fuel injection, no distributor in the ignition, so relatively decent ignition system. And this car was exhibiting kind of a strange symptom, this bucking, jerking sort of. It felt like not all the cylinders were firing, or not all the cylinders were firing completely. So, one of the first things you want to do when you're trying to diagnose a drivability problem is determine when under what conditions the problem happens. So, if you have some sort of a mechanical failure, let's say you have a burnt valve or a bent valve, or a cam lobe that's worn out, or a broken valve spring, or you've got rings that are shot, you'll have this poor performance all the time. These things don't change under different driving conditions. If you've got a problem related to fuel, like not enough fuel pressure or something like that, that problem is going to show up under those times during the engine operation where you need a lot of fuel pressure. If you have some sort of a spark problem, that's going to show up under conditions where it's difficult to create a spark. So one of the things you're doing when you're doing diagnosis, first thing when a customer complains about some sort of symptom is try to find out when that symptom happens. Is it all the time? Is it on acceleration? Is it at idle? Is it only when the engine's cold? Is it only when the engine's warm? So these symptoms don't always happen all the time. So we had this Crown Vic, and it would only exhibit the symptoms, this bucking, sort of jerking symptom, cruising on the highway going up a slight hill. And I drove the car kind of a lot trying to narrow it down to exactly when does this happen. So I would go out on on 219, 65, 70 miles per hour, and cruise along, steady cruise. So you're not heavily into the accelerator. You're just enough accelerator, or even put the cruise control on, just to keep it going that speed. And then that road is pretty hilly. So I'm driving along at a steady speed and the car's running fine. But when it starts to climb a little bit of a hill and try to maintain that speed, it would start to, that's when the symptom would start. Definitely felt like cylinders, at least one cylinder was misfiring, and probably multiple cylinders were misfiring. So kind of make a long story short, what was happening, watching scan tool data and all that, is when it gets up to cruise and it's cruising along for a little while, the computer really leans out the air fuel mixture. Why would it do that? Fuel economy. So cruising along, lean air fuel mixture. So that's checks one box, right? Lean air fuel mixtures have higher resistance than rich air fuel mixtures. So across the spark plug gap now, you're making it more difficult for the spark to jump. So it hits this little incline, and just that extra little bit of load, right, brings the cylinder pressure up just enough. That's when the thing started to really misfire. So what fixed it, what wound up fixing it, was a new set of spark plug wires. So the wires had, reached that point where they were okay when the vehicle was idling. They were okay even under heavy acceleration where it's rich, but lean air fuel mixture, a little bit of a load, put the two together, and that's when they failed. So the new wires fixed it, and it's just something to keep in mind when you're trying to diagnose something, like what's going on there and under what conditions does it happen. I don't remember how I decided to put wires on it. I think we checked the spark plugs. May have even changed the spark plugs. This is going back several years, so I don't remember. Anyhow, it definitely felt like an ignition misfire. And an ignition misfire, it's kind of, the characteristic is that it, it's affected a lot by engine load. So that's about all I want to talk about now. That's the end of this module 1, the slides for that. So when you're done watching this video, by the time you watch this video, there should be a test/quiz available on Blackboard. If it's Sunday night and you're watching this, then that test won't be available yet. It's going to come up on Monday morning at 8 o'clock, and it'll be there all week. Don't wait, because you want to take an opportunity to try it, and then you can go back and look through the slides and stuff, or even rewatch some of these videos. You can go back and take the test again, and hopefully, everyone should ace it under those conditions.